All right, here we go. So a statement can be written in if-then form or symbolic form. P implies Q, so that's what that arrow means. It means implies. So if P is true, then it goes to there. So the hypothesis is the phrase that follows if. So if you remember like 7th grade science class when they had the science fair, or was it the science fair? I think it was called the science fair. But that's the one where people would make their science experiments, and they had that the steps of science, and one of those things was the hypothesis. So the hypothesis is what you think is going to happen. Then the next part would be the conclusion, which the conclusion is the phrase that follows then. So if something happens, then something else. So an example, so identify the hypothesis and conclusion in the following conditional statements. So if you live in Nashville, then you live in Tennessee. Now, I don't know if schools still have students remember the states and the capitals, but I knew when I was in 5th grade, we did have to memorize the states and the capitals. So let's see. Yeah, Nashville is in Tennessee. So if you live in Nashville, then you live in Tennessee. Yo, live in Tennessee. All right. So that's the hypothesis. And that's the conclusion. So again, conclusion is kind of like what you think, what you know has happened or is happening, and hypothesis is what you think is going to happen. All right, next one. So we have one that looks like it deals with math. If the sum of the measures of two angles is 90 degrees, then they are complementary angles. Okay, so again, there's the if. So again, if is the hypothesis, and the then is the conclusion. So if the sum of the measures of two angles is 90 degrees, then they are complementary. So hypothesis, again, that means what we think is going to happen. The sum of the measures of two angles is 90 degrees. So if that is true, all right. So sometimes it may or may not be true. But if it is true, then this statement is what we would go with. They are complementary angles. All right, next one here. A quadrilateral is a square. Then it has 4 right angles. So a quadrilateral is any 4-sided figure, and it doesn't have to be a square or a rectangle. It can be a diamond shaped, or it can be a trapezoid shape where it's like a square, but one side is smaller than the other. Okay, so just because it says quadrilateral doesn't mean it's a square or a rectangle. But if a quadrilateral is a square, then it has 4 right angles. So the hypothesis is a quadrilateral is a square. So if that's true, then that would mean it has 4 right angles. All right, so let's go ahead and move on a little bit more down. All right, if an angle, writing conditional statements, write each statement in if-then form. An obtuse angle has a measure greater than 90 degrees. And that's true. That is the definition. It said, if we were to have a definition of an obtuse angle, that's what it would be. An obtuse angle is something with angles greater than 90 degrees, with at least one angle greater than 90 degrees. So we just have to put the if and then in there. If an angle is obtuse, all right, so if an angle has one angle greater than 90 degrees, then it has a measure greater than 90 degrees. So again, we just split it in there, putting the if and then. Now what you cannot do is reverse it, all right? So if we said, if it has well, actually in this case, in this specific case, I think you can reverse it. And I think some other ones can be reversed as well. But don't reverse it, just try to keep it into the try to keep it in the order that they gave it to you at. So if it has a measure greater than 90 degrees, then it is obtuse. So in this case, those two can switch, and it would still make sense. I'm going to see if there's one that I can point out that does not have the ability to go backwards. So let's go to number 5. All numbers are divisible by 4 are also divisible by 2. So again, that's just a statement, and that's true, because if something can be divided by 4, then it can also be divided by 2. So if I pick like 16, which can be divided by 4, it can also be divided by 2. Anyway, the statement would go, if a number is divisible by 4, then it is also divisible by 2. Now this one I think cannot be reversed. Okay, cannot be reversed, so it doesn't always work. So just, again, this is not part of it. But I know some students are going to put them backwards every once in a while, thinking that it's going to work, like it's an addition problem or something. But if it is divisible by 2, then a number is divisible by 4, and that's not true because 6. Okay, that 6 is the immediate number. That would be my counter example. 6 can be divided by 2, but it cannot also be divided by 4. So again, some of them don't work, so just keep them in the same order, all right? That's what I'm getting at. I'm just telling you, keep them in the same order. Okay, so again, if a number is divisible by 4, then it is also divisible by 2. That makes sense? All right, number 6, next one. States on the East Coast border the Atlantic Ocean. So if a state is on the East Coast, then it borders the Atlantic Ocean. So again, you just put the if and then in there. So just sort of turn this definition into an if and then statement. And there's usually 2 statements in there too. So again, the first statement was if a state is on the East Coast. The second statement would be then it borders the Atlantic Ocean. All right, and so some of these we can kind of take something out of them, kind of like the you live in Tennessee, then you live in Nashville, or I'm sorry, the other way around. Here, I was just talking about not getting turned around. If it is Valentine's Day, then it is February. Well, that makes sense because there's only one Valentine's Day and it's in the middle of February. There's, you know, if some time traveler comes out from the past or from the future or wherever, and he asks you what day it is, and it so happens to be Valentine's Day, and you told him it's Valentine's Day, they probably would know that they're in February. They probably immediately know the date as well. Unless, of course, it's so far in the future or so far in the past that they wouldn't have Valentine's Day in the future, then I guess not. They wouldn't know. But for most people in the immediate past and the immediate future, yeah, that makes sense. All right, let's go ahead and go to the next one. Prime numbers have 2 factors, 1 and itself. And this one's a pretty easy one because it looks like there's already a comma in there. If a number is prime, then it has 2 factors, 1 and itself. In this case here, actually, it does not split at the comma because, you know, it seems like it would, but it didn't in this case, so be careful with that. So if a number is prime, and in this case, it seems like they actually changed this whole one because it didn't say prime numbers, it says if a number is prime. So some of these you might have to change a lot. You have to change the wording, the grammar. And again, it's not always going to split right at a comma where you would think it would be. You know, I would imagine this would have split at the comma myself. But then if I wrote it down, I probably would have read it and said, okay, that doesn't make a whole lot of sense. I'm gonna have to change it a little bit. So that's one of the things you're gonna have to do with these is change them up a little bit, make sure that you know which one, you know what you're talking about, and to make sure it makes sense. All right, so yesterday we covered a couple of these things here. So I'm gonna give you a second or two to write them down, but I'm gonna leave this up here just in case you're still writing some of that. So I'll give you a minute or two to finish this up, and then, or if you're already finished with that, we'll go ahead and start down here. Whew. That's good. Ugh. All right, hopefully you're almost done with that top part because I'm going to scroll down in just a second. Just clear a couple of things out here. All right, so are we ready to go down? There we go. So this way, when I'm going over it, you can kind of follow along more than trying to write and understand at the same time, because if you try to do both, it's not going to be that easy, right? So it's going to be a little bit easier if you're able to write it down, then we cover it. That way you write it down, you already know kind of what we're going to say, and when you hear it again, it'll kind of make sense. So it's just sort of like repeating something over again. Repetition. So we'll see how that goes. I think we're just about ready. I would imagine so. If you're not, don't be afraid to leave something in the chat that says, okay, can you go back up really quick? All right, but don't overuse it because there is kind of a pacing I'm trying to go with, the timing that I'm trying to stick with. Okay, so what we got here, inverse. So inverse is formed by negating the hypothesis and the conclusion. So it's not P, and that would be not Q. And remember that squiggly line, let me go back up there and show you, it says implies. So not P implies not Q. So remember, negation is what we did yesterday, or negating. And that was just saying, just adding the word not in there yesterday. So yesterday I used the example of squirrels are rodents would be my original statement. And if I change it to the inverse, it would be, or the negation, it would be, well, in this case, if I had to negate both of them, it would be not squirrels are not rodents. Which kind of seems like it would make sense, but then just because something's not a squirrel doesn't mean it's not a rodent, because it could also be a rat or a mole. I think moles are rodents. A rabbit I know is a rodent. All right, so that would be negation. And then you also have switching, and this is kind of what we talked about before when we were talking about switching the order of P and Q. So Q would now lead to P. So in that same statement, well, and I already did some of them with the above examples because I was saying something like, remember, you can reverse some, but most of them you can't. Or I don't know how it goes, but some of them you can, some of them you can't. Let's just keep it at that then. So in this case, I'm going to stick with my squirrels example. So rodents are squirrels. And in that case, again, it doesn't quite match because yes, all squirrels are rodents, but then not all rodents are squirrels. Because you can have other rodents besides squirrels. So sometimes it doesn't work out. Okay. And then so we said not, so again, this is just adding the word not. This is reversing the order. And this one here is negating and switching the hypothesis and the conclusion. So that one would actually be kind of both of them. So in this case, that would be not rodents are not squirrels. All right, so hopefully they have some better examples than I did. All right, so I mean, hopefully that you kind of understand what they're getting at, but I don't know. Let's just move on. Hopefully that works out because again, all you need to do is just fill these in here, right? So let's see, write the inverse, converse, and contrapositive of the following conditional statements. Determine the truth value, and if it's false, provide a counterexample. All right, so they start off with, if it is Saturday, then there is no school. So the inverse, so that would mean, again, negating it. So putting the word not in there. So if it is not Saturday, then there is school. So they had the word no in there. So be careful with that. Pay attention to this one right here, because they have a no in there already, right? They said there is no school. So when you take the inverse of that statement, you have to change it so that there's no more no. And now it says there is school. So that would be the inverse. So you have to reverse both statements, either by putting in a no or not, or removing it. All right, so hopefully that makes sense. Truth value, false. Okay, that is a false statement, because there is another day there is no school. Sunday is another day that there is no school. Because if somebody said, okay, well, it's not Saturday, so there must be school. Well, what about Sunday? What happened to Sunday? All right, so the converse. So converse, again, you switch the hypothesis and the conclusion. So if there is no school, then it is Saturday. And this one has the same truth value. It's still false, because in this case, you would still have a Sunday as an option. So if there's no school, then it is Saturday. So again, they switched it. So instead of it is Saturday, there is no school, then there is no school. They switched the if and the then. All right, so let's see. If there is school, then it is not Saturday. So looking at this here, let's talk about the contrapositive first. So it says, remember in the original it says, if it is, or we have to switch the order first. So kind of start from the converse, I should have said that before. Start from the converse and then negate it. So if we look at the converse, it says there is no school. So here we would say if there is school, so we negate it. Then it is, well, in the original it says then it is Saturday, but here it says then it is not Saturday. So again, we have to reverse the no or the lack of no in there. Ooh. And in this case, it would be true. So if we read the entire statement, if there is school, so imagine that you are at school, is there a chance it could be Saturday? No, right? There's probably not a chance it would be Saturday. And I'm pretty sure someone's going to come up with something that's going to say something like, oh, well, Saturday school, if you need to make up time or whatever. Which, yeah, Saturday school is sometimes a thing. I don't know if it's a big thing anymore. I know like a few years ago it was a big thing, but I don't think it's as big as it used to be, or I don't know if this school does it or how they do it. I know I haven't done it, and I haven't done Saturday school in a while, or Sunday school for that matter. But again, these are just sort of mostly true statements, sort of like I'm pretty sure if I look into the animal kingdom thingy, I'm pretty sure I could find a squirrel that isn't a rodent. And it would probably be like a Goliath beetle or something like that, you know, because there's like bugs that have animal names. Or a stag beetle, you know, it's like if someone came up with the joke of like, you know, when is a stag not a deer? Well, when it's a beetle. All right, so again, that doesn't really count because I know we have other things like elephant seals are not actually elephants. Anyway, go ahead, let's go on to number 10. If the product of two numbers is odd, then both numbers must be odd. So that's the original statement. If the product of two numbers is odd, then both numbers are odd. So again, that means multiply. So if I multiply two numbers and it's odd, then both of those numbers that we use to multiply must have been odd. So I kind of said it a little bit more with a little bit more words in it, so it hopefully makes a little bit more sense. So let's go ahead and find the inverse. So in the inverse, again, we just switch it. So if the product of two numbers is even, so we have to negate whatever word is in there. So in this case here, the word is odd. So we could have said not odd, So like if the product of two numbers is not odd, well, not odd, there's only one other option, okay? If a coin doesn't land heads, then it has to be tails sort of thing. So if it's not odd, then it must be even. So that's why we changed it to just even. And the second part here, then the numbers cannot both be odd. So originally said the numbers must be odd, but we can't really change the vocabulary, so we just say cannot be odd. And again, we have to, well, I could imagine another way of saying this. We could have said this another way, but this is okay. This is probably a good way to say it. So is that true? Well, okay, so let's look at the whole thing. If the product of two numbers is even, so if we multiply two numbers and it comes out to be even, then the numbers cannot both be odd. Now, if you remember, if you multiply, well, there's only 4 combinations. I can multiply 2 even numbers, you know, like 2 times 2, that would be 4. And that means that they were both odd and the number was odd. The product was even, and both numbers were even. Ooh, okay. See, now I'm getting kind of turned around because there's a lot of changes. And if I had, it says cannot be both odd. So what would happen if they are both odd? Well, if I had like 3 times 3, that would be 9. So that would give me an odd number. Well, what if I picked one odd and one even, like 3 times 5? That would be 15. So in that case, you know, finding all of the outcomes, that would be true. This statement here is true. Because if the product is even, then both of the numbers, you know, couldn't have both been odd. All right. Ooh. Converse. So in this case here, remember, that's the one where we switch the placement of the hypothesis and the conclusion. So here it says talking about the product. Over here it says both numbers. So if 2 numbers are odd, then their product is odd. Is that true? Well, yes. Like I was just saying, 3 times 3 is 9, 5 times 5 is 25. And there's, you know, we could try a couple of other numbers, but I'm pretty sure that it would be true. Now, again, for contrapositive, you're starting from converse, but you're adding the not in there. So if 2 numbers are not both odd, in other words, you could probably also say even, but I'm pretty sure they did not say that because in the very next statement, it says then their product is even. So if 2 numbers are even, then their product is even. Well, that's kind of true, and I already kind of mentioned that, right? Because if I have 2 times 2, that's 4. 10 times 10 is 100. 20 times 20 is, well, you get the idea. All right, I'm going to go ahead and go down to the last one, and I'm going to check the schedule. Just a reminder, we did start a little bit late. I was having computer problems this morning. Something happened with, what is this program I'm using? Edge? Is that what it's called? Oh yeah, Microsoft Edge. And it wanted me to update it. And I said no, because I didn't want to have to wait a while to have it updated. And then it just wouldn't work. It would go really, really slow to where it was almost frozen. So I had to restart my computer. So I'm going to check the schedule and I might have to adjust it in order for it to fit our class. Okay, I got the schedule right here. What we might do, just because if we were to follow the break as we tried to, we would not have any independent student time. So what I might do instead is I might just kind of skip the break, and that's going to take us almost up to lunch. We lost pretty much the entire break. So what I'm going to do is I'm probably just going to keep going. I'm just gonna, we're probably, well, maybe we'll have like a 10-minute break for like getting up and walking around or something, but we'll see. Okay, let's see. If the temperature is 25 degrees Fahrenheit, then it is below freezing. Now in this case, I probably have to look this up because I don't know the difference between Fahrenheit and Celsius. And All I know is that Celsius is generally hotter at the same number. So like if I had 100 degrees Fahrenheit, well, that would be kind of hot. But 100 degrees Celsius, you'd be like, I don't know, like burning or something. Well, probably not on fire, but like it would be super, super hot. It'd be like oven hot. Like literally oven hot. I don't mean like you get in your car in Phoenix after parking it outside and now it's like, you're like, oh man, it's like an oven in here. Not like that. I mean like an actual oven. So again, I'd have to look these up, but we're going to go with them. So if the temperature is not 25 degrees Fahrenheit, then it is not below freezing. And again, I'd have to look this up, but it says false because I guess 20 degrees Fahrenheit would be not below freezing, which is one thing I'm weird about Fahrenheit. I think it was Fahrenheit that said 100 degrees is boiling. No, that's Celsius. Celsius 100 degrees is literally the temperature at which water boils. I don't know, Fahrenheit's kind of a weird one. I wish we would just get rid of it. I don't know. I don't know why we keep it, but oh well. All right, next one. If the converse, so remember that's the one where we have to switch the order of the sentences or the statements. If it is below freezing, then the temperature is 25 degrees Fahrenheit. And I didn't really change it all that much because the truth value is exactly the same and the counter example is also still the same. So in a way, these two kind of probably mean the same thing. Contrapositive, if it is not below freezing, so again, going from the converse, they add the words not in both statements. So if it is not below freezing, whereas this one here, it says it is below freezing, then the temperature is not 25 degrees. So we know it's not below freezing, so the temperature can't be 25 degrees. And that's true because, well, there's a whole bunch of, well, I don't know, just leave it at that. Sorry, I'd probably mess it up trying to explain it. I really need to brush up on my science stuff. All right, I'm gonna go ahead and go down to the next page, and we'll be done with this one here. Let me look ahead really quick. So the conditional statements, and then looks like there's going to be a quiz, and then it goes into Venn diagrams. The Venn diagram was one that looks pretty short, and I know Venn diagrams are kind of easy. So I'm going to try to get to this page. I'm going to go through this page here, and because of the weird schedule thingy, I'm going to finish this page. I'm going to finish this page and the next one. So go ahead and start writing it down. It's been about 25 minutes since we started this one, and it should go until about 50 minutes. Oopsie. All right, just double checking my attendance. Because I'm gonna have to turn this in later on today, and when I turn it in, who knows? Okay, oh boy. Biconditional statements. So this is kind of the same as what we just got done covering. So again, if you remember what I was saying last week when we were starting the whole thing, by means two. So, right off the bat, that means that there's a clue that we're going to be doing two of something. And conditional means, again, something that's happening. So the definition of that would be the conjunction of the conditional and its converse. So the symbolic form would mean if P implies Q and then Q implies P, you would write this double-sided arrow. Hello? They should be marked, but yeah, what I want to do, and I was going to go down there and tell you this during the break, but I wanted to include week 3 and 4, so that way they would get them at the same time, because I don't want the last week to come down and then students would be telling me they don't have their packets. Yeah, so they should be just about done now. Okay. Bye-bye. All right, so where are we? Read as P if and only if. So that's what that little double-sided arrow means. If and only if. So truth value, biconditional statements are true when both conditional and the converse are true. So again, conditional is like the original, and then the converse is if, if not. So like, I mean, I'd probably come up with an example, but it probably wouldn't be as good as the ones they would have. So I'm gonna just sort of stick with I'm just gonna stick with the lesson. All right, I'm gonna go down a little bit. All right, so given the biconditional statement below, write both the condition and its converse. Determine the truth value of the biconditional and explain why it is true or false. So the conditional here, so we have our original. Two angles are supplementary if and only if their measure is 180 degrees. So we got to put the if and then statement in there. So if two angles are supplementary, then the sum of their measures is 180 degrees. So here they have the if and only if. So we broke that down and we separated it so it's got a then in there. So again, we create the if and then statements. All right, so converse. So we got to add the word, well, sorry, this is the one where we switch them. If the sum of two angles measures 180 degrees, then they are supplementary. And in this case, they are both true because, again, 180 degrees means that it is supplementary, and supplementary means that it's 180 degrees. So in this case, it's true both directions, right? Conditional and converse, they're both true. All right, I'm gonna go down here. And again, I'm gonna leave a little, I try to leave a little bit up here, so as long as you're not like way behind, all right? But there's no reason you shouldn't be way behind either, okay? I don't want people turning their Zoom on and then running off to go play Fortnite or something. All right, I wear my snow boots if and only if it snows. Well, that makes sense. So let's make it into an if and then statements. If I wear my snow boots, then it snows. Okay, that you might have to think about that one, but it doesn't really seem to make sense at first. So if it snows, then I wear my snow boots. So again, converse means that we switch the order. If it snows, then I wear my snow boots. So again, this is an example of one that is not reversible. So I was talking about how some of them can be reversible. This one is not, and it's, again, you have to think of it at first. But the second one makes a lot more sense because if it snows, all right, so you look outside, oh no, it's snowing. I don't want my good shoes to get wet. Or I don't want to get snow in my foot, on my foot. Then I wear my snow boots. Okay, that makes sense. What doesn't make sense, and that's why they call it false here, the conditional is false because it says if I wear my snow boots, then it snows, right? So it's like right now, okay, right now it's like well, I was just talking about degrees a second ago, but it's like 98 degrees outside. So it's a fairly hot day. Well, probably we'll get that time. It'll probably get that hot around lunchtime. All right, but if it's like today and it's a nice hot day and I think, oh man, you know what, I could use some snow. Let me go grab my snow boots and I put them on. Then all of a sudden it starts snowing. Okay, that doesn't work that way. It doesn't work that way because boots do not cause the snow, but snow can cause someone to wear their boots. So that one again is a really good example of one that is not reversible. Okay, so x squared equals 25 if and only if x is 5. All right, so let's see that. Let's put that out. So in the conditional again, that's when we add the if and then. So if x squared is 25, then x must be 5. And that kind of makes sense because if I have 5 and I square it, I get 25, right? If we plug it in or substitute it, substitution is the correct word. If x equals 5, then x squared equals 25. So if we reverse it, it still kind of makes sense because if I have 5 and then I square it, I get 25. That's true, and that's always true. But the truth value, and again, this one would seem like it would make sense at first, and I would imagine some people would say it's true. So, but this one's a tricky one because the conditional is false because there is another, because it says it has to, okay, so then our conclusion is that x has to be 5. But does x have to be 5? No, because it can also be -5. If I have -5 and I square it, that would be -5 times -5. And if you remember, a negative times a negative will become a positive. So no, this one doesn't work up here because there is another one. That would be my counter example, is because x could be, or x is equal to -5. All right, so number 4, I will get 10% off and, I will get 10% off if and only if I spend at least $75. All right, so some coupons are like that. In fact, I had a coupon code shoot, I don't think I've even used it. I was gonna use that coupon. But I got one in an email that was saying something like, if you buy more than, it sounded exactly like this. If you buy $75 or more, you will get a 10% off coupon or free shipping or something like that. But sometimes a lot of those coupons do have conditional statements like that. So to put it in the conditional, right? If I get 10% off, then I spent at least $75. And that sounds true, right? Because if you spend exactly $75, they will give you the 10% off. If I spent $80, I will still get the 10% off. So that one makes sense. The converse, so again, we have to flip the order, the conclusion and hypothesis. If I spend at least $75, then I get 10% off. And that one is reversible, okay? It's not like these last two where they're not reversible. Sometimes they are, you can reverse them and it still makes perfect sense. And in this case, that's true. They are both true. Both of them made good statements that are true. Okay, so I'm gonna go ahead and move on. And like I said, we're gonna do this one and then we'll take a break. I'm pretty sure we'll be done with this in time. It's not a really long one. It's just a lot of stuff, writing and kind of going from here to there. And I'll give you a little bit of time to write them down before we go over them. Whew. Mind your P's and Q's. Graphic organizer for logic statements. So compound statements, those are the ones that we were covering yesterday. And those are the ones that basically say that the word and or make a difference. You know, that it'll change everything depending on how you say it, you know. Directions, let's see, use the statements below to write the compound statements. So it gives us some statements here. So statement P says that vertical angles are congruent. Q says that 15 is a prime number. And it looks like they wrote the exact same statements here. So P and Q. And here you have P or Q. So remember with and, you want both of those things to be true. So just to like to apply for a job, kind of the basic rule, and I know this is not the exact rule, but they usually say something like you need a identification card and a social security card. You need those two things, right? If you only bring one, if you only bring the social security card or an ID, they're not gonna take it. For some reason, they want both. Okay, so one is not good enough. They have to both work. They have to both be there. With an or statement, sometimes it'll be something like, well, if you don't have an ID, you can use a student ID or a driver's license, something like that. You know, driver's license also works as an ID. So you can use an or on that one. So some places will let you use them as an ID. You know, if it's not really that important, you know, if it's not like applying for a job or getting a driver's license, sometimes they'll let you use like a student ID. Like sometimes if you go to the movie theater, you can get a discount with it. All right, so let's see what their statements say. Vertical angles are congruent and 15 is a prime number. So that first one is true. Vertical angles are congruent, and that's the one that says if you have two lines crossing each other, the angles opposite of each other or across from each other are going to be the same. So that one's true. 15 is a prime number. So a prime number can only be multiplied with 1 and itself. Like in this case, if 15 was a prime number, it would only have the factors, meaning numbers that you could multiply to get to it, of 1 and 15. So to counterexample that, I'd have to come up with at least one set of factors that are not 1 and 15, which is pretty easy, 3 and 5. 3 times 5 is how you get 15, and that's one other set besides 1 and 15. So in this case, that would be false. But again, if it's an and statement, they both have to be true. If one of them is false, then the whole thing is false. And this is the exact same thing, but they only switch out the word or. Vertical angles are congruent, or 15 is a prime number. And again, or means only one of those will make me happy. Right? So like if I said, I want pizza or hamburger, and I get one of them, I'll be happy with that. But an and statement would be like, I want mashed potatoes and gravy. All right, if you only get mashed potatoes, I mean, you could live with it, but it wouldn't be as good with if it didn't have the gravy. Or if they gave you gravy with no mashed potatoes, you know, it's like, well, I guess you could use it as a dip. But either way, it's not as good. All right, so just, you know, they have to go together pretty much. And in that case, it would be true because vertical angles are congruent. Even though 15 is not a prime number, we only need one of those statements to be true for the whole statement to be true. All right, so I'm gonna go ahead and go down here to conditional statements, and hopefully you're done writing that. In fact, I'm gonna go all the way down here. There's not a whole lot of writing. So with conditional statements, and again, there's a lot of stuff, but this one page here is really good for remembering it. In fact, you know what? I don't know what's on the back of this page. I would like to say rip it out and keep it, because this is a really good reference to keep. I guess you could, no, because then I wouldn't get the work if it's on, if there's a backside with work on it, then I wouldn't get it. But probably the best thing to do would just be copy this somewhere else, okay? Take this page, copy it in a notebook or on a piece of paper and keep it because, well, you're probably gonna need it because we're gonna have a few tests later on. And any page that's kind of like this, any page that says, you know, graphic organizer or anything like that, keep those somewhere. Well, keep a copy of it somewhere somehow. All right, anyway, statement P is that it is St. Patrick's Day. Q is that it is March. So again, remember this says P implies Q. So the conditional has the if and the then added to it. So if it is St. Patrick's Day, then it is March. Well, that's true because, again, if the time traveler woke up, if a time traveler appeared in front of you, then that would mean that, if the time traveler appeared in front of you and you told him that it's St. Patrick's Day, then he knows he's definitely in March, assuming he knows his holidays, or she, I guess, time. I can only think of one time traveler that was a woman, and that's Doctor Who. I could be wrong. I'd have to think about that some more. Anyway, that would be true. Inverse. So inverse, remember, that's the one where you make them both not statements. So it is not, if it is not St. Patrick's Day, then it is not March. And that's false. And my counter example to that would be, well, what about the day after St. Patrick's Day? That's still March. Or the day before, or any day before or after St. Patrick's Day, still in March. You know, St. Patrick's Day is only like one day, so there's like 30 other days in that month that are not St. Patrick's Day. So that would be a false. All right, converse. So converse, remember this is reversing it. So Q implies P now. So if it is March, then it is St. Patrick's Day. Again, the same one as the one above it. So some of these flow in different directions. Some of them are reversible, some of them aren't. Some of them can be, have the not added to both of them and it still works out. But in this case here, it is not, it still doesn't work. So if, for the same reason as the top one, if it is March, then it is St. Patrick's Day because there are still 30 other days that are not St. Patrick's Day. Ooh, okay. And contrapositive goes off of the converse. And you can kind of tell because they both start with the word con. All right, so con means, well, let's just keep it simple. Con, they're both flipped order. So if it is not March, then it is not St. Patrick's Day. Okay, so it's not March. So it's any other month, then it can't be St. Patrick's Day. That's true because there's only one St. Patrick's Day in 1 month, and that is March. So that would be true. All right, so by conditional. So by means two, so two conditions. It is, so again, this kind of means that it's got that arrow, and remember that arrow means here, if and only if. And that means, again, they're true with the conditional and the converse are true. So let's check the conditional and the converse. Converse and the conditional. So that's this one and this one. So they both have to be true. So one is true, the other is false. So if there's even one false, that means it can't be true. So again, that means that you can, it'll kind of go both ways. And that arrow there is the clue that it is going both ways. All right, so like I said, we're gonna go ahead and wind this down. If I follow the schedule, it says that we should come back at 9:45. So as always, I'm going to go ahead and get ready to, start the independent student learning time. That's the time that you will have to ask questions about the work. So far I haven't been getting a whole lot of questions about the work. And I don't know if that's a good thing or a bad thing, because if I'm getting questions, you know, it can mean that I'm not covering things that well. But it could also mean that people aren't really trying, students aren't really trying. So it's always tough, because it's like, okay, well, what's going on? You know, what's going right? So make sure you ask questions, because the one thing I don't want to be hearing at the end of this course is, oh, Mr. Nez never gives help. Okay, well, that's what we're doing for the next couple of minutes. All right, that's your time to ask for help if you need it. If we need to go back or cover anything, you know, that's the time to do it. So that we have time, especially in our day, just for that. All right.